Chapter 2. What is cryptography? This chapter covers basic terms used in cryptography. What is an unbreakable cipher? What are the different types of cryptography? Cryptography is often called the art of secret writing. It is more than that. It encompasses everything from invisible inks to transmitting messages by quantum entanglement of photons. In particular, cryptography includes the making and breaking of codes and ciphers. Different authors use cryptographic terminology in inconsistent ways, so let us begin by agreeing on some basic terms. Plain text or clear text is the message or document that you wish to keep secret. In traditional cryptography, the message was text written in some language known to both sender and receiver. In a computer setting, this could be any type of file such as a PDF, text, JPEG, image, MP3, audio, or AVI, multimedia. A cipher is a method or algorithm for garbling a message to make it unreadable, for example, by changing the order of the characters or by replacing some characters with different characters. In general, ciphers operate on individual characters or groups of characters in the text without regard for their meaning. A key is a secret piece of information known only to the sender and the legitimate receiver, or receivers, that selects which transformation is used for each message. For example, if the cipher method is to change the order of the letters in a message, the key might specify which order to use for that day's messages. A key can be a letter, a word or phrase, a number, or a sequence of letters, words and numbers. The strength of a cipher is highly dependent on the total size of the keys it uses. A keyword or key phrase is a word or phrase used as a key. Encryption or encipherment is the process of changing the plain text into an unreadable garble by the legitimate sender who knows the key. Ciphertext is the resulting garbled, unreadable message or document which will be transmitted or stored. Decryption or decipherment is the process that the legitimate receiver, who knows the method and the key, uses to turn the garbled ciphertext back into the original plain text message. A code is also a method for garbling a message to make it unreadable. By contrast to a cipher, a code normally operates on words or phrases in a message. A typical code replaces words or phrases with groups of digits or letters. Confusingly, the word code is also used to mean a standardized representation for letters such as Morse code. Hopefully, the meaning will be clear from the context. Cryptology is the formal study of cryptography, the mathematics and methodologies used for constructing and solving ciphers. Scholars study cryptology. Code breakers study cryptanalysis. Cryptanalysis is the study of codes and ciphers for the specific purpose of identifying weaknesses and finding ways to break them or, conversely, ways to strengthen them. Code breaking is the process of solving encrypted messages by third parties, enemies or opponents, who do not have the key and may not even know the method. This can be done by mathematical methods or by the patient amassing and collating of intercepts, but in practice often comes down to the 3 B's: bribery, blackmail, and break-ins. Section 2.1. Unbreakable ciphers. Now that we have some common language, let me address the main issue. What exactly do I mean by unbreakable? First, I mean that a cipher cannot be broken by cryptographic means. This excludes break-ins, bribery, coercion, defections, extortion, honey traps, and similar means. Those lie outside our scope. Second, I mean that the cipher cannot be broken in a practical sense. Any opponent has finite resources and finite time to devote to the code-breaking task. When choosing a cipher, you need to have some idea of how much manpower and computer power your potential opponent may expend on breaking your cipher. Make a conservative guess, allow for improvements in computers, add a margin of safety, and pick a number. Then, when you choose a cipher, you have a target to aim for. Reach that target and your cipher is effectively unbreakable. Remember that many messages have a limited lifespan. If your message is "attack at dawn" and your enemy reads your message at noon, it's too late. You have already attacked. A cipher that can be broken in 12 hours is effectively unbreakable when your opponent does not have 12 hours. Just to make this concept doubly clear, when I say that a cipher has been broken, I mean that an opponent can read the messages sent using that cipher. Even if the opponent can read only 1% or 0.01% of the messages, the cipher is broken. But there is a cutoff somewhere. If the opponent can read a message only if they have intercepted many messages of the same length enciphered with the same key, or where 63 out of 64 key bits are 0, then the cipher is still unbroken. The opponent has no a priori way of telling which messages used which key, or which keys are nearly all 0. It may never happen that you send 2 messages with the same length and same key, or where 63 key bits out of 64 are 0. If your cipher uses a 256-bit key, and an enemy cryptanalyst finds a mathematical or computational method to reduce this to 200 bits or even 150 bits, that cipher may be weakened, but it is still unbroken if your chosen level of security is 128 bits. Using a 256-bit key to achieve a security level of 128 bits provides a huge margin of safety. When the government decided that the old data encryption standard was no longer safe, it held an international competition for a new cipher. Proposals were solicited worldwide. Dozens of ciphers were submitted. Hundreds of cryptographers evaluated these candidate ciphers for security, speed, and ease of implementation. There were 3 rounds of winnowing, lasting from 1997 to April 2000, until a winner was chosen. That's what you need to do when your cipher is going to be a worldwide standard for governments, banking, industry, and the military. If you decide to enter the next competition, this book will help prepare you. Most readers, however, will not attempt that. Their ciphers will have more limited scope. They may trust their own judgment, or whatever verification process they devise for evaluating their ciphers. The principles in Chapter 12 will help guide them to a sound and confident decision.